Hello, my students. This is a brief video that will focus upon the basics about the classic atomic experiments that were conducted in the very late 1800s to the early 1900s, the work of Thomson, Millikan, and Rutherford that advanced the most basic model of the atom that John Dalton communicated. Thomson, and working with Millikan, made the first discovery about the subatomic particles, that atoms were made of smaller pieces and contained smaller pieces, and then Rutherford built upon that. In Chapter 2, we only lead ourselves and leave off with the Rutherford model. So, what you are responsible for knowing are the three classic atomic experiments, that's what they're known as, who conducted them, what was the name of each, what was the basic setup of each of the experiments, what were the main findings, and then how was that applied to understand the atom. As far as the models of the atom, what is different about the Dalton versus the Thomson versus the Rutherford model. In Chapter 7, we'll pick back up with Rutherford and then get ourselves to the modern model of the atom. John Dalton, moving forward from Democritus' original idea that matter was composed of small things called atoms, predicted that the atom was a solid sphere. He didn't have any evidence that there was anything smaller. And Dalton and Democritus and everyone that believed and then saw the evidence of atoms definitely predicted they were spheres. Spheres are the most efficient design, particles, the shape that leads to the most efficient packing and maximizes attraction. That's where we go with the sphere. Now we can, of course, see them and confirm that they are. So what wonderful forethought. However, in 1898 to 1903, a gentleman by the name of J.J. Thomson, he was actually an English physicist, conducted the cathode ray tube experiment. The cathode ray tube, first known as a Crookes tube, was a glass tube that was evacuated, but a small amount of gas remained, very, very small amount of gas. So it was a gas under very low pressure. At either end of the tube were metal plates, and these metal plates were connected to a battery. And we know that a battery has a positive and negative, so when this was turned on, this would induce a positive charge and a negative charge to the corresponding plates. The anode is the positive, the negative is the cathode. So hence the name cathode ray tube. When the voltage source was connected, something amazing happened. A ray, a beam of light was created. This perplexed scientists throughout the world. J.J. Thomson worked for 5 years. He did various things, put magnets to the outside, and the magnets would cause the ray to bend. Well, then they knew that whatever this ray was, it itself had to have a charge, because only charged things would respond to a magnet. They tried things like putting a paddle wheel, like the Gateway Clipper, inside. And when they would turn on the battery, it always moved toward the anode. They would do things like put a stationary cross. And what they found is that whenever the battery was turned on, a shadow of the cross was always cast on the anode side. Through much of this evidence, it concluded, first, that whatever is being created must have some oomph to it, because something is hitting the paddle wheel and causing it to move. And at first, they thought it was light, which if you shine light on something, It's not going to necessarily make it move. So there had to be something substantial to this ray. No matter what metal they tried, no matter what gas they put inside the cathode, they got the ray every time. They knew they were charged from the magnet exposure. So, through many other examples, day in and day out experimentation, J.J. Thomson predicted that the ray was made of negative particles. What he could do with the strength of the magnets, the amount of deflection of the ray, was actually come up with what is known as the charge to mass ratio of these particles, which he concluded they were particles because they were causing this paddle wheel to move. They were being generated at the cathode. That's why the paddle wheel was always moving toward the anode. That's why the shadow was being created, because the ray was generating from the cathode. Well, what things are attracted to positive but negative? Now, upon analyzing exactly this value, he was predicting that these were incredibly small. Pause and enter Robert Millikan. Robert Millikan was conducting what is known as the oil drop experiment. He had a big metal barrel. Inside the barrel were 2 metal plates, and these metal plates were also connected to a battery. He had a viewer that had a magnifier, and he would sit day in and day out and watch into this viewer. There was a very thin hole in the top of the metal plate, and he had an atomizer, a spray. In essence, you could think of a hairspray bottle, or a bottle of spray oil when you're cooking, and it would create a spray, a cloud of tiny oil droplets. Now, this slit was big enough that the oil droplet could then pass through, and gravity would pull it to the bottom, of course. He had an X-ray generator. When hitting this barrel with X-rays, it would cause the oil droplets to become negatively charged. All right, back to Thomson. Well, these gentlemen were working at the same time. Again, Robert Millikan. J.J. Thomson chose to go ahead and predict that what was happening was that particles were being ejected out of the metal atoms. He predicted then that inside the atom there were incredibly small, by looking at this charge to mass ratio, incredibly small negative pieces. He chose to call these negative pieces electrons. He didn't know exactly the mass, exactly the charge, but from this value, he had an idea that they were incredibly small. What Millikan predicted was when the X-ray hit the air inside, it actually was causing electrons, which J.J. Thomson discovered, to leap onto the oil droplets, causing them to be negatively charged. He hooked up the battery such that the negative plate was at the base, the positive plate was at the top. Now, why would he observe? Now, we may get 5 electrons, we may get 100 electrons, we may get half a mole of electrons. So these oil droplets became of varying charges. What he would do was vary the voltage on the plate such that he could suspend the oil droplet, because when he got the negative charge to be just enough, it would repel the negative oil droplet. The positive charge just enough, it would attract. So the repulsion and the attraction would suspend the drop. He would make a note of the charge, or the voltage he needed. Do another series. Suspend one, note the charge. And he found that they were multiples of the same value. What Robert Millikan was able to do with the oil drop experiment was find the charge of the electron. So, back to Thomson, we now got the charge, we could determine the mass. The mass of the electron was found to be 1/2000th the mass of a hydrogen atom. J.J. Thomson was astounded by his results. Hydrogen was the smallest atom, and what he found was something 1/2000th the size. He didn't even believe the data himself. He then developed the plum pudding model from his results. That will be in the next short video.